Hello, let's look at worksheet 10-5, which is all about secant lines and segments, the last worksheet of topic 10. So number 12 here, Cindy is asked to find the measure of angle VXZ. What is the error? So she said, I'm going to take half of this arc plus this arc. But since this is a secant angle with its vertex outside the circle, we shouldn't be adding the arcs, we should be subtracting the larger arc minus the smaller one. So she should subtract the arcs instead of adding them. Arcs instead of adding them. So we should do 1/2 of, in this case, 96, the bigger one, minus 24. And that should give us 36 instead of what they got. Number 13, given circle P, secant CA, and tangent CD, what is the area of circle P? So we're going to need to find the radius of the circle. And in order to do that, we might be thinking about our theorem about the segments that touch the circle and go through the circle. And that, in this case, would be the theorem that tells us that this piece outside the circle times the entire secant is equal to the piece of the tangent multiplied by itself. One of the last theorems we did in the notes. So in this case, 6 squared, because that is the piece outside of the circle and also the entire thing, equals the piece outside the circle of the secant 4 times the entire secant, which is 4 plus x. So when we do this, we get 36 equals 16 plus 4x, and we solve. And of course, we get 5 equals x. And it's saying, okay, well, what is x, right? X is going to be, in this case, the part of the secant that runs through the circle, which corresponds to the diameter of the circle because P is on that line. That center of the circle is on that line. So if the diameter is 5, the radius is 2.5. And if the radius is 2.5, we know that the area of the triangle is the area of the circle is pi times 2.5 squared, which is equal to 6.25 pi. You might have had that as a more expanded decimal, and that is okay, but 6.25 pi works just fine. Number 14, given circle T and tangents AD and CD, what is the measure of angle ADC? Well, when we think about this, I see an inscribed angle with a measure of 72. That means the intercepted arc of that angle has a measure double that of 144. And since that is a tangent angle, that means that the rest of the circle has an arc of 360 minus the 144 that we found. So the rest of the circle, I can't draw very well, has an arc of 216 because 360 minus 144 is equal to 216. So then we can find the measure of angle ADC, the tangent angle, by doing 1/2 of the difference between the arcs. The larger arc, 216, minus the smaller arc, 144, is going to give us 36 degrees for that angle. Numbers 16 and 17, we've got chord angles here. We know that when the vertex is inside of the circle but not at the center, we're going to do half the sum of the arcs. So to find angle 1, that's got arcs for itself and its vertical angle, which are 106 and 80. So we do 1/2 of the sum, 106 plus 80, which is going to give me 93 degrees. Number 17, I have the 81 degree angle, but the arcs I'm looking at are part of, or they go with, the other set of angles, the ones that are supplements to 81. So I do 180 minus 81, and I get 99. So I know that the angle is 99. So I set up the equation. 1/2 the sum of the arcs, x I don't know, but 122 I do, equals 99, that angle measure. Then I can multiply both sides by 2 to get rid of the 1/2 and get x plus 122 equals 198. Subtract 122. And I find out that x equals 76 degrees. Number 20, here we've got an inscribed angle and we have a secant angle. We want to find the measure of angle RTV, which is the secant angle. We know our inscribed angle has a measure that is half of the measure of the intercepted arc. So we're doing double 47 to get the measure of the intercepted arc. When we do that, that is going to be 94. And that gives us 3 arcs of the circle. The only arc we don't have is SU. So we're going to do 360 minus the rest of the degree measures in the circle. So 360 minus 138 minus 94 minus 98. That's going to give us 30. So the arc from S to U is 30 degrees. Since we have a secant angle we're finding, which is vertexes outside the circle, we've got to do 1/2 the difference of the arcs. So 1/2 of 94 minus 30. This gives us 1/2 of 64, which gives us a 32 degree angle. Numbers 21 and 22, we've got some of this segment multiplication. 21, we've got a chord segment, so the longer piece times the shorter piece of a singular chord is equal to the longer piece times the shorter piece of the other chord. A times 4 in this case is equal to 6 times 6, so 4a equals 36, divide by 4, and a equals 9. For B, we've got the piece of the secant outside the circle multiplied by the entire secant is equal to the piece of the secant outside the circle multiplied by the entire secant. So 5 outside the circle times b plus 5, the entire secant, is equal to 6 outside the circle times 15, the entire secant, because 9 plus 6 is 15. So we get 5b plus 25 equals 90. Solve that. Divide by 5, and we find that b is equal to 13 units. Let's keep going. On the back, we've got this fountain. Chris stands in the position, I guess it's a sculpture, not a fountain. Chris stands in the position shown to take a picture of a sculpture with a circular base. Chris is deciding which lens to use. What is the minimum view angle from where he stands so he can get as much of the base as possible in the picture? So when he's looking at the edges of the fountain, he can't see around the back. He can only see a tangent line with the fountain. The edge, or the last furthest point out of the statue that he's going to see, is the point tangent to the statue, and the point tangent to the statue on this side. So he's got a tangent angle. This is asking us to find the measure of that tangent angle. What is that view angle that we can use to get the most possible sculpture in the picture when we stand 4 feet away from the sculpture? So let's think about that. I'm actually going to draw some segments. I'm going to draw the segment that is tangent, or sorry, from the point of tangency rather, to the center here, because that's going to make a right angle. We know that makes a right angle. And I could do the same thing on the bottom if I wanted to as well, but I'm just going to do it on the top here for now. And here's some things that I know, right? I know that I know that the diameter, rather, of the sculpture is 5, which means the radius of the sculpture is 2.5. I know that the piece, or the distance that the photographer is standing away from the sculpture, is 4. which means that the entire length from the center of the sculpture to him is 2.5 plus 4, which is 6.5. I'm looking for an angle measure. When I know two side lengths of a right triangle, I've got to use trigonometry. And if I want to find this angle measure right here, I have opposite over hypotenuse. I'm going to use sine. So let's come down here. Say for A, I'm going to say the sine of A, I don't know my answer, we'll call that x, I guess, equals opposite 2.5 over the hypotenuse, which is 2.5 plus 4, or 6.5. And if I go ahead and take the inverse sine of both sides, I get x equals the inverse sine of 2.5 over 6.5. That's going to give me x equals 22.6 degrees. Now that's not the answer. That's only half the angle, because he's only looking at the top half of the angle right there. We also have to double it because we have two halves of that angle, from his line here towards the right and towards the left. So we're going to say that we double that. So the angle is equal to 45.2 degrees. And that's the answer for A. For B, we have to think of a different idea. If Chris uses a lens with a view angle of 40 degrees, what is the shortest distance he could stand from the sculpture? So he's going to change this amount now. He's going to have 40 degrees, but he's going to change this amount. I'm going to use the bottom right triangle to figure out this problem. So instead of thinking of the angle as the one I just found, 22.6, I'm going to think of this angle as half of a 40-degree lens angle, or 20 degrees. So if that's 20 degrees, I still know that the radius of the sculpture is 2.5. And now I want to find how long, here's another 2.5, I want to find how long the hypotenuse is if I know the opposite. So I'm going to write for B, I know that the sine of 20 degrees, I'm using 20 now because that's half of a 40-degree angle, equals the opposite, 2.5, over the hypotenuse. And the hypotenuse is just whatever x is. We got to figure that out. So I'm going to say, all right, let me go ahead and manipulate this. I'm going to multiply both sides by x. So x sine of 20 equals 2.5. Divide both sides by 20. X equals 2.5 over the sine of 20. So I'm going to figure out what that will be. 2.5 over the sine of 20. It's going to be 7.31. And so then, that's not exactly the distance he could stand, though, because that's 7.31, the entire thing. I need to take away 2.5, because that would be the radius of the sculpture to figure out how far away he really needs to stand. So I'll do 7.31 minus the 2.5 radius of the sculpture. And I get 4.81 feet that he has to stand away from the sculpture. Number 26. Excuse me. A satellite orbits above the equator of Mars as shown and transmits images back to a scientist in the control room. What percent of the equator is the scientist able to see? So we're going to assume that this distance here is the equator, going around the planet from here to here and then kind of behind it where we can't see. He is able to see all the way to what in his idea is the edge of the planet and the edge of the planet, which is really the tangent and the tangent line, because we can't see behind the point of tangency. So what we can do is we can say, all right, this is giving us two arcs. It's giving us the x arc that goes this way, and then the rest of the circle can be represented by an arc of 360 minus x. So what we do is if we know this piece right here, the 42, we can set up an equation for a tangent-tangent angle, half the difference of the arcs, and say half of the arc that's bigger, we call that 360 minus x, minus the arc that's smaller, which is just x degrees, equals 42. And since there are two x's in here, we can solve. We can say, all right, 1/2 of 360 minus 2x equals 42. We can go ahead and multiply both sides by 2. 360 minus 2x equals 84. And then subtract 360. Negative 2x equals negative 276. Divide that by negative 2, so we get x equals 138. So he's able to see 138 degrees of the equator, but the question is asking us about what percent of the equator is that. Well, the equator all around would be 360 degrees. So we're just going to do 138 degrees divided by 360 degrees to get our percentage, which is going to give us 38%. So he can see 38% of the equator from where he's at. Number 28, for what measure of arc UW does this measure equal 34? We'll call this an x degree measure, and we can find our tangent-tangent angle equation. They say that the measure of TVX is 34. We'll take half the sum of the angles. So the difference, half of 112 minus x, we don't know x, equals 34. Multiply everything by 2. 112 minus x equals 68. Subtract 112. We get negative x equals negative 44, which means x equals 44. So that missing arc is a 44-degree arc. And finally, number 29, given circle P and the secants that we have, what is FG? So we're using our secant segment algebra here, where the outside piece times the entire secant is equal to the outside piece times the entire secant, and setting up an equation. Outside piece 3x outside piece x minus 5 minus the entire secant 3x is equal to outside piece x minus 6 times the entire secant 4x. Multiply all that. We end up with 3x squared minus 15x equals 4x squared minus 24x. Then we can subtract 3x squared from each side. We get negative 15x equals x squared minus 24x. Subtract 24x from each side. We have to add 24x to each side. We get 9x equals x squared. And I can divide both sides by x there. And I get 9 equals x. And so then I just have to plug it in, because we want to know how long is FG. So FG is 9, or x minus 5. So 9 minus 5 gives us 4. So FG equals 4, or answer B. If you've got any questions on this, don't hesitate to ask. Please let me know. And hopefully this gets you done with your topic 10 worksheet packet.